So I'm going to do a video here on the measures of central tendency, and what that really means is when you gather data, um, your data falls into, when you organize your data, it falls into different categories, and what ends up happening is usually, I shouldn't say always, but usually your data always ends up um, can be organized in a way that you'll find that it tends towards the center. And by that I mean we're going to look at three things: the arithmetic mean, or what we call just the mean, the median, and the mode. But for this video, I'm just going to focus on the mean. All right. So I'm going to get rid of those, but I just want to point out that those two are in fact um, parts of the measures of central tendency. Well, the arithmetic mean is the average, and the way you calculate the arithmetic mean is, let's say we had well, I have some nieces and nephews, and their ages are something like one. Trying to think. Well, my own daughter is one, and then we have a 3-year-old, another 3-year-old, 5-year-old. Actually, we have another 5-year-old. We have a 6-year-old, a 9-year-old, 11, and a 12. And so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm actually missing 2 children. I can't think of who they are right now, but that's okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 children. I know that's not correct, but that's all right. And so to find their averages, I just add them all up. And it's going to be 1 and 1 is 2, 5, 8. That's going to be 18, 24, 33, 44, 56. So when I add up all of 10 of these children, I get 56. And I divide by 10. And this is the sum. And this is the number of children. And so the average age of all my nieces and nephews, and my own children I should say, is 5.6 years. And that's the average. And that makes sense because take a look. 5.6 would fall someplace around here. And like we said, it's a measure of central tendency, and all my nieces and nephews and my own children are born to my brothers and sisters, which have their own range of ages, and it makes sense that they're all fairly close together. Anyway, there is one other thing I want to say about the average. I mean, that's pretty much it. You just add up all the scores and divide by the total number of scores. Sometimes they'll say like you'll get SAT questions. They'll say Seth took 4 exams. His average for 3 was an 80, and then they'll say something like can Seth raise his average to an 85? And so what you have to do is, we don't know what his actual 3 exams were, his first 3 exams, but what I do know is if their average is 80, I'll just assume they were all 80. And the 4th exam, I don't know. Well, I want his average to be 85 for 4 exams, so that'd mean he'd have to have 85 times 4. That's going to be 20, and that's going to be 32 plus 2. That's going to be 340. And so when I add these 3 up, I get 80 plus 80 is 160. That's going to be 240. Plus x equals 340. I have to subtract. Goodness me, I'm having a hard time writing 240. Subtract 240 from both sides, and take a look at that. I just whipped this question right off the top of my head. If Seth gets 100 on his last exam, the new average will be an 85. So yes, it is possible. Anyway, so that's video 1. I hope you liked it. I'm going to do another video on median and mode and one on range. You'll learn more about that soon.